This is the third problem from Objective 2. The squares below are arranged in a sequence to produce a geometric pattern. Which expression can be used to determine the perimeter of a composite figure made of S squares arranged in this pattern? And I see I have 4 different figures here. Each one adds 1 square to the previous one. And it looks like each side of the square is 2 units. So what I'm going to do is make a table. We'll have the number of squares and the perimeter. So first we have 1 square, and it has a perimeter of 2, 4, 6, 8. Next we have 2 squares, perimeter of 2, 4, 6, 8, 10, 12. Then we have 3 squares, 2, 4, 6, 8, 10, 12, 14, 16. And our last figure has 4 squares, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. So for this column, my squares increase by 1 each time. On here, my perimeter increases by 4. So if we were using x and y as our variables, my slope would be the change in y over the change in x, or the rise over the run. My rise would be 4. It's constant because these change, so I'd get a straight line. And this is constant, so everything's good. I have a straight line. Y equals mx plus b. My slope is 4, rise over run. My y-intercept, here I don't have that yet. That would happen where we have 0 here. So using the same pattern, we would take away 4, and we'd get 4 there. Now it doesn't make sense with squares and perimeter, but for writing the equation it will work. So my y-intercept is 4. And looking at my answers, the only one that matches is this. We can test it. Of course, we already have all the data here, and we can see that it works. 4 times 4 for this last one is 16, plus 4 is 20. And that would work on each one. Now, this is not the only way, of course, to do this. You could test each one of these with the data that we have and see what works and what doesn't. Let's just do that. Let me change colors. Okay, 8s. So on 1 square, 8 times 1 is 8, and that works. On 2 squares, 8 times 2 is 16. And, does not work for 2, because 2 is 12. Let's look at b. When s is 1, 8 times 1 is 8, minus 4 is 4, but it's supposed to be 8, so it doesn't work already on the first one. And then d, 4 times s, 4 times 1 is 4, but it's supposed to be 8, so it doesn't work. So we've found 3 that don't work. We can use it on this one. 4 times 1 is 4, plus 4 is 8. That works. 4 times 2 is 8, plus 4 is 12. So that one works. 4 times 3 is 12, plus 4 is 16, and it works. And finally, 4 times 4 is 16, plus 4 is 20. And it works on every single one. So make sure that you check every single one, because they'll work on part of them but not the others. Another thing we could do is plug it into the calculator to check. That's just 4x plus 4. Delete this other stuff. There's the graph. We want to look at the table. Make sure it matches ours. 0 is 4, sure. 1 is 8. 2 is 12. 3 is 16. And 4 is 20. If we enter any of these others, like let's do 8s minus 4, so 8x, take away 4, and I graph that and look at the table, you're going to see it does not work. 1 is 4 and 1's supposed to be 8. So calculator still helps.